All right, so in the last video, we talked about randomized controlled trials and how they make things super easy for us, right? All we need to do if we've got this randomized controlled trial is compare the treatment group to the control group, right? We get the average difference that we observe is the average effect of the treatment, right? The average treatment effect. So that's very easy. It gets us to that causal effect that we're after, right? The problem is we can't do randomized control trials to answer all the questions that we would want to answer, right? And just to illustrate that, let's imagine that what we really wanted to get at was a causal estimate of the long run effect of being in a high school that has a shooting, a mass shooting in it, right? So think about what that would entail. First, there's the ethical dimension, right? You would have to randomly assign students to experience a mass shooting, right? Obviously, that's not an ethical thing that we could reasonably do. But putting that aside, right? If we wanted to get at that effect, it would cost us, if we wanted to even just like measure the long run effect of anything, right, from a randomized controlled trial, we would need to spend a lot of money to follow up with those individuals in the study for years and years and years. And then on top of that, if we wanted to answer that question, we wouldn't be able to answer that question until we got to the long run, right? Because we'd have to look at those long run outcomes. So we could ask that question today, put that study in process, right? Obviously we couldn't do it for a mass shooting study, but if it was like some other, extended school days or something like this, right? We wanted to know long run effects, right? We could put that study into place. We could put that randomized control trial into place. Maybe we get it going by next year, right? And then if we're looking at long run outcomes, right, we got to track those kids down 10 years from now, right? So we couldn't actually get the answer until 10 years from now, right? So that is the downside of randomized control trials. They're big, they're expensive, they're time consuming, and for a lot of questions, they're not really feasible from an ethical perspective. Okay, so we've got all these other approaches to try to get at the causal effect of some treatment, to try to come up with a counterfactual that might not be as good as if we were doing a randomized control trial. It might not be a perfect counterfactual because we're not like totally randomly flipping a coin to put individuals in the treatment or the control group, right? But we've got some trick to sort of get as close to an apples to apples comparison as we can, right? And there's sort of a spectrum of how well we're doing. Economists call it internal validity, right? So how close we're getting with that counterfactual to what we think the true counterfactual would be, right? The comparisons that we're making. Okay, so one option that we're going to talk about in this video is including control variables in sort of a typical regression, right? So what that entails is making an assumption about how treatment is assigned, right? Before we were with our RCT, we're assuming the treatment is totally randomly assigned, right? When we're including a control variable, we're assuming the treatment is randomly assigned, conditional on some specific variable or set of variables. So to get some intuition for how this actually works, right? Let's go back to our example from before, where we had our infrastructure program, our Hearts and Minds infrastructure program we've got some data for, and we've got these 5 cities, and now we've got this additional variable called high poverty. And let's say we know, or we're going to at least assume in this case, and we're going to, for the moment, we're going to take this assumption as correct, that treatment status is assigned randomly within each poverty group, right? So when it was decided which cities are going to get this infrastructure program, They looked within the high poverty cities, and then they flipped coins for each of those high poverty cities. They looked within the low poverty cities, and they flipped coins for each of those cities that were low poverty. Okay, so we got random assignment, but it's conditioned on this variable high poverty. So let's see what that does to our sort of equation here, where we were looking at, if you recall from before, right? We had our observed difference was equal to the treatment effect plus the selection bias. So let's see whether this assumption helps us. If we know that this is true, where does that get us? Let me put it that way. Okay. So here we can make a little bit of a stronger case. And I'll show you what I mean here. Let's look not across all the cities in the treatment group and the control group. Let's just look at the high poverty cities. So we're gonna look at the observed difference between the treatment group and the control group, but within the high poverty cities where xi equals 1, right? And we're going to do our same little trick over here where we added and subtracted this counterfactual, but we're going to add and subtract the counterfactual within the high poverty cities only. Let me clean this up a little bit so you can see it. Okay, so what does this do for us? Well, let's take a look at this piece here. Right? What's that saying? That's saying that the potential outcome without the treatment for the group that's treated and is also high poverty, so the high poverty group that's treated, minus the potential outcome without the treatment for the group that's not treated that's high poverty, right? But we've made this assumption that conditional on poverty, treatment is randomly assigned, which means that without the treatment, both of these groups would look the same, right? So these two things are going to cancel each other out, right? And we've sort of, we've gotten rid of the selection bias here. It's just that we've gotten rid of it within sort of a narrower subgroup, right? Right, so we've got the, we can look at what we've actually got here. We can sort of add this up for the high poverty group. Is this the high poverty group? What do we got here? Yeah, so high poverty group, we've got Ramadi, we've got Decrete, and we've got Kirkuk, right? So we're taking the average of the high poverty treated group, so that's Ramadi and Kirkuk, right? 250 plus 300 over 2, minus the average of the high poverty not treated group, which is just Kirkuk, right? So for the subgroup of high poverty cities, we're getting this treatment effect of minus 50. Yeah, so high poverty group, we've got Ramadi, we've got Decrete, and we've got Kirkuk, right? So we're taking the average of the high poverty treated group, so that's Ramadi and Kirkuk, right? 250 plus 300 over 2, minus the average of the high poverty not treated group, which is just Kirkuk, right? So for for the subgroup of high poverty cities, we're getting this treatment effect of minus 50. Okay, so we can do the same thing with the low poverty group, right? Same sort of idea, right? We're just conditioning now. We're adding this condition on xi equals 0, right? So we're just looking at xi equals 0. And again, right, since conditional on poverty, there's this random assignment of treatment, this group that ends up getting treated would have looked the same as the group that didn't get the treated if neither of them received the treatment, right? So this guy's going to cancel out there as well, right? So when it comes to our treatment effect, again, we can look up here and we can say, okay, we're looking for just the treated group that's low poverty, right? Treatment status 1. So that's Karbala. And then the non-treated group that's low poverty. That's the non-treated group that's low poverty. That's Mosul, right? So our treatment effect for this group is going to be 125 minus 150 equals minus 25. Oops, equals minus 25. Equals minus 25. Okay, so we've got sort of treatment effects for these two pieces, right? We want to look at the average treatment effect, right? So all we're going to do is we're going to take the weighted average of these two effects, right? So if the effect is minus 50 for the high poverty group, and there's 3 out of 5 cities are high poverty in the sample, we're going to take 3/5 times minus 50 plus the other 2/5 times this minus 25, and we get minus 40. Okay, so that would be our average. Well, let's call it the average causal effect, just to highlight what we're talking about, right? We're after that causal effect. So we get a causal effect for the high poverty cities, we get a causal effect for the low poverty cities, and then we get this average causal effect by combining those two estimates, right? And each of those, if our assumption is right, each of these should be correct, right? Because with each of these, we're eliminating the selection bias because we've got this, perfectly random coin flip. It's just that we've only got it within these certain groups, okay? So another way to think about this is running a regression, right? This is basically what you do when you run a regression, right? You're doing this sort of automated matchmaker thing. It's what mastering metrics likes to refer to it as. So this would be like running a regression that looks like this here, right? Where before we just had, if you remember before, we just had this one variable, DI, which was just the treatment, right? So basically we're just looking at the average observed difference before. Now we're looking at the average observed difference, but within this high poverty and low poverty groups, right? So when we run this regression, we refer to xi as our control variable. Right here we're talking about just an indicator for high poverty. It's 1 if it's high poverty, it's 0 if it's not. And the estimate that we get for beta is going to be our average causal effect, so long as our assumption is correct, that there's no correlation between our treatment variable and what's in our error term, conditional on poverty, right? So that's the same thing as saying, like we were before, that we've got something that is at least as good as randomly assigned, conditional on high poverty.